Hello, and welcome back. Today, we're seeing rapidly why CubeSats have overwhelmed our orbits and how, in the near future, they might be of impact around our solar system. This technology was first developed in 1999 in a collaboration between the California Polytechnic at San Luis Obispo and Stanford University. The goal was to enable students and researchers to access space for exploration and studies. Since then, it has become an always more common way to access space also for enterprises and businesses. In fact, small CubeSats can be sent to orbit cheaper because they won't be the main payload of the launch. They will be a piggyback or secondary payload, paying a cheaper ticket, not getting a perfect deployment, but still reaching their orbit. What do we mean when we say CubeSat? Well, the sat part means that it is something that is in an orbit around something else in space. Satellite. The cube part instead refers to the standard dimension of these devices. They are usually divided in cubic units, or U's, which take up to 10 by 10 by 11.5 centimeters and weigh roughly 1.33 kilograms per U. For reference, a bottle of water of 1 liter weighs 1 kilogram. Also, these units can be stacked to assemble bigger and more complex CubeSats. What are now standard CubeSats are brought into orbit by a launcher, big rockets like the Ariane 5 or the Falcon 9. As said before, they are inserted into an orbit, just not the right one. So, it is important that the propulsion subsystem is capable of correcting the orbit and to keep the correct attitude. This simply means keeping its antennas pointing at Earth. The most common and developed device for this purpose is a cold gas thruster. On a CubeSat, a little tank contains some inert gas, something that does not tend to explode, and is released through a nozzle to provide thrust. It typically uses a valve to control the mass flow and hence the thrust given. Usually, only 1 liter of fuel is carried, and it takes up a full U of space. Other space is taken up by the sensors required by the scientific mission. Then, an onboard computer is required both to analyze the data acquired and to compute the thrust required for attitude control. And they also need for an energy source to keep all systems active and to allow for the antennas to beam the data back home. All the systems described up to now are ignoring the thermal issues and radiation shielding that must all be taken into account when designing a CubeSat. The subsystems discussed up to now are valid for classic low Earth orbit or LEO CubeSats. They just get deployed into orbit by a launcher and are only required to keep the trajectory with small corrections and the attitude control. But what is becoming more and more interesting is the deployment of CubeSats beyond Earth orbits and into deep space. The first issue is that the launcher will not be releasing the CubeSat into an orbit, but it's gonna release a spacecraft that then will bring the CubeSat out of Earth's orbit and into deep space. Once the CubeSat is in space, what will the environment be like? What about the radiations, and are our assumptions on the space environment correct? Well, that is what we want to study actually. But a real challenge will be how to navigate the CubeSat. It will be very far from Earth, so it is unthinkable to control it by hand. Commands would be sent through radio waves that travel roughly at the speed of light, but when a CubeSat is millions of kilometers from Earth, it would just be too much lag. So the CubeSat will have to be capable of autonomous navigation. This means that the CubeSat will need to accommodate a dedicated system to map its surrounding and understand if it is on the correct path or not, and how to correct its trajectory. This is of paramount importance if it has a target to reach or if it has to avoid an obstacle. So, the first mission to deploy CubeSats in deep space beyond Earth orbit has been the 2018 Mars Cube 1, or MARCO in short. 2 twin CubeSats were sent as secondary payload on the InSight mission. Their goal was not to do a scientific experiment, they just needed to build a radio bridge to allow communication to reach Earth-based ground stations, particularly during the infamous 7 minutes of terror, the crucial landing phase which has claimed the majority of humanity's probes during their landing on the Red Planet. However, as early devices, they had no propulsion systems and their mission was relatively short. After they served as radio antennas over an alien planet, they simply drifted away after a flyby around Mars. The mission's success, however, sparked the interest of scientists in CubeSats for this new, harder, and more interesting part of space. The next big missions will be around the potentially hazardous asteroid 65803, Didymos, and its small moon Dimorphos. The asteroid is classified as hazardous because its trajectory passes a bit too close to Earth, and we all know how it went last time. NASA has invested in a planetary defense-driven research program, the Double Asteroid Redirection Test, or DART mission. The goal is to prove that impacting an asteroid can deflect it in a measurable way, even if hit with just a small object. Hopefully, this can prove that a small impact on an hazardous asteroid can deflect it enough to make it no more hazardous. This will ensure us that we won't go on the same way as the dinosaurs. DART should launch from Earth as the secondary payload of a Falcon 9 in 2022. It will then proceed to the targeted asteroid. DART will be carrying also a CubeSat to the targeted asteroid, the Italian CubeSat for imaging asteroids, or LiCaCube. The CubeSat's mission will be to monitor the efficacy of the impact. On the other hand, the European Space Agency's mission, HERA, will deploy 2 CubeSats to map the asteroid's surface and perform radio science experiments. HERA's objective is to perform a close-up investigation of the results of DART, as this will be the first object ever in the solar system to have had its orbit shifted by humankind in a measurable way. And it will also analyze the effects of the impact on the whole binary system of Didymos and Dimorphos. HERA should launch in 2024 on board of the Ariane 6 and should reach Didymos system after DART's impact. The new frontier of research is deep in space, and CubeSat technology is ready to scout the new areas for us and to keep us safe. I hope you enjoyed this video, and if you wish to have a more exhaustive video on some details of CubeSats or on specific missions, please leave a comment below. Also, consider subscribing if you're interested in more high-tech videos, and if you enjoy my content, please consider supporting the channel by liking and sharing this video. Hope to see you next time!